Hello students, today we are going to discuss a phenomenon related to science which deals with the position of an object. So before we proceed for that discussion, let's have a look at some of the pictures and tell me what you conclude from those pictures. So here is the first picture in front of you. As you can see, there is a football lying on the ground, and in the second frame you can see a ball is rolling. So what do you conclude from these two frames? Of course, you must be saying that the football is at rest, and the second frame that ball is in motion, that means it is rolling. Correct. Coming to the second frame, as you see, in the first frame, a boy is sitting on a bench, and in the second frame, we see a boy is walking. So, what do we conclude from this again? We see that the first frame, the boy is at rest, and in the second frame, we see the boy is in motion. So, definitely you must have guessed that today our topic of discussion will be your chapter 8, that is motion. So dear students, in this chapter we shall first learn to describe the motion of object along a straight line and express such motions through simple equations and graphs. So today we will focus on describing the motion of the object along a straight line. As in the previous slide, we saw in that frames in the picture, and we were discussing about rest and motion. So when we say an object is at motion or an object is at rest, what does that mean? When we say that the object is at rest, that means that object is not changing its position with respect to time. And when we say that an object is at motion, that means the position of that object is changing. So dear students, in order to specify the position, when we say something is moving, an object is changing its position, how can we say that an object is at rest or an object is in motion? That means we see that the position of that particular object is changing with respect to time. Whenever we are observing, being an observer, when we observe an object, if the position is changing, we say it is in motion. If the position is not changing, then we say it at rest. Now, as we know, to specify the position of an object, we need a reference. For example, I may be standing 5 meters away from that wall, but my position will be different when you compare with yourself. I may be standing several kilometers away from you, but I am the same person standing at the same place. That means when we specify our position, we need a reference point. With a different reference point, my position will be different. And what do we call that reference point? We call that reference point as origin. So whenever we are specifying the position of an object, whether it is in motion, whether it is at rest, we describe that position with a specific point, and that is called as your origin. So if I say I am standing 5 meters away from the wall, for me the wall is a reference point. And if I say I am standing several thousand kilometers away from you, that means my reference point is you. And again, so many students are watching this program, so for them the distance will vary. So depending on the reference point, the distance may vary or the position may vary. For example, if you look around in your room, in around the corner, there are several objects are there. So in order to specify a position of a particular object, suppose you ask your younger brother to bring a book, you specify a position. That means you give a reference the book is in the almirah, in the second almirah, or in the second shelf, or in the third shelf, we always give a reference. So that particular reference is called as origin. So I hope you clearly understood what is origin. Now, when we talk about motion, as we discussed in the beginning also, the simplest type of motion is motion in a straight line. That means an object traveling or moving in a straight path. That is the simplest type of motion we can describe. So today in this module, we will discuss about motion of object in a straight line. So when we talk about straight line, at that point, if you look at here, let's talk about a situation. We have already defined about the origin. So here in this picture, the O indicates the origin, the reference point. Suppose an object starts from the point O and travels up to a point A. That means we say that object has moved or object has changed its position from O to A. So that means it has traveled certain distance or it has covered certain path. Now that particular object again moves from A to B. That means as you can see at B, the indication is 35 kilometer. Suppose I say the object further moves to point C. Then we see that mark is 60 kilometer. So if I ask how far the object has moved, how will you calculate that? We calculate that the total path covered by that particular object. So here if I say object has moved from O to C through A and B. First it moves to A, then it moves to B, then it moves to C. So if we calculate the total path, that gives us a 60 kilometer. That means we can say here that the object has traveled a path of 60 kilometer, and that total path covered by an object is called as the distance traveled by that. Now let us take another situation. The same object again comes back to a position B. Now if I want to specify the position, the change in the position of that particular object, in that case what do I say? How far the object has moved. Are you going, because in the initial time it has traveled to 60 kilometer, again it moves back to 35, that means it again traveled a distance of 60 minus 35, that is your 25. That means total distance covered by is 85 kilometer. But if you see the distance from O to B, if we observe right now, what is the position of the object? The position of the object is at B. So here, in order to specify the initial and final position of an object, we introduce another term that is called as the displacement. So displacement does not depend on the path through which the object has traveled. Rather, displacement depends on the initial position and the final position of the object. Here in this case, if I say the displacement of the object is not 85 kilometer, rather it is 35 kilometer. Because in case of displacement, we are more concerned about the initial position and about the final position. It's not concerned about what path it has traveled. Let us take from a day-to-day life example. Suppose you start from your home, you went to the market, you purchased something. The market is around 5 kilometers away from your home. After purchasing something from the market, you came back to your home. So with respect to your home, when you come back, is there any change in your position? The answer is no. That means have you not moved any path? Again the answer is no. Although you have traveled certain path, but here in this case if you observe that your initial position and final position is same, so we introduce two different things. One is called as the distance, another is called as your displacement. So in this particular case, the distance and displacement, when we talk at that time, the only difference is that in case of distance we only talk about the magnitude, but in case of displacement we not only talk about the magnitude but also we talk about the direction. We went in the direction of the market, then again came back, so we are specifying the direction. So distance is a phenomena only connected to the magnitude, whereas displacement we have both magnitude as well as the direction. So I hope now you have understood what is displacement and what is distance. So distance is the total path covered, whereas displacement is the shortest distance between the origin and the final position, or the shortest distance between the initial position and the final position. So many instances we can say that displacement can be 0, but distance cannot be 0. If you have traveled certain part, that means your distance has to be some have magnitude, but it is not true that always the distance will be is equal to the displacement. Suppose if I travel from point O to point A as shown in the figure, I start from O, I went to point A, now my distance travel is 25 km, and at this position if I calculate my displacement, that is also 25 km, because I am moving in a particular direction. That means my direction is from O to A. But if I reverse my direction, that is from again if I come back 5 km back from A towards O, that means I am specifying towards O, that means I am coming back. So now if I say what is my distance and what is my displacement, is the distance and displacement are same? The answer is no. My distance here will be O to A, again from A to 5 km back, that means 25 plus 5, that will give 30. But what will be my displacement? My displacement will depend on the initial and final position. So initial position at 0, final position is at the 20 km mark. So the displacement will be 20 km. So here in this case what we see? We see that the distance and displacement are not same. So dear students, to conclude this, your distance will be always the total magnitude, total path that you have covered, but displacement will be always the between the initial and final position, what is the shortest distance. So moving on to the next part. To see, as you can see, also you can see the definition of your distance and displacement. Many a time it is asked in the examination also to write the difference between distance and displacement. As you can read it out, to describe distance we need to specify only the numerical value and not the direction of motion. The numerical value of physical quantity is its magnitude. The shortest distance measured from the initial to the final position of an object is known as the displacement. So as we have already discussed about distance and displacement, let's solve a simple numerical related to distance and displacement. You can see it on your screen. The question is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So here the time duration has been mentioned and the sides of the square field has been given. So we need to calculate the displacement of the farmer from any particular position in 2 minutes and 20 seconds. So I guess all of you can give a try for it. What will be the displacement? So dear students, let's try to solve it. So if you see, let's assume this is a square field A, B, C, D having a side of 10 meter. So if the farmer starts from position A, comes to B, then to C, then to D, then A, that gives a complete round. So in one complete round, what will be the total distance travelled? The total distance travelled will be the perimeter of the square. That means 10 meter into 4, that is 40 meter. That means the farmer moves a distance of 40 meter in 40 seconds. So the time duration given here is your 2 minutes 20 seconds. That means total 140 seconds. So if we apply unitary method, the farmer moves 40 meter in 40 seconds. So how far he will travel in 140 seconds? The answer is very simple, that is 140 meter. So now if he is moving along the boundary of the square field, that is 140 meter, he has travelled 140 meter alongside of the boundary of that square field. Our task is to now calculate what will be the displacement. And as we know, already we have discussed, displacement is nothing but the shortest distance. So if we calculate here in 140 meter, how many round that farmer will complete along the side of the square field? So that means if we give 140 divided by 40, that will give us 3.5. That means 3.5 round. So when he completes 3 round, his displacement will be definitely 0. Then half means 20 meter. 20 meter means how? From A to B 10 meter, then B to C again 10 meter. So after 140 seconds, the farmer will be at the position of C. That means if he has started from the position A, after 140 seconds, he will be at the position C. Now, how do you calculate the shortest distance between A and C? The shortest distance will be the diagonal, that is AC. And if you apply here Pythagoras theorem, then you can find out the distance between A and C will be the square root of AB square and BC square. That means you will get, that is the root over of 200 meter, and that will give you the answer as 10 meter, that is 10 root 2 meter. Root over of 200, that is 10 root 2. So here the displacement of the farmer in 140 seconds will be the shortest distance, that is AC, because the initial position will be A, final position will be C. Hence the shortest distance will be the diagonal, that is AC, and the diagonal will be 10 root 2 meter. I hope you understood. So this is how we can apply the concept of distance and displacement. So now let's talk about some other phenomena associated with change in the position. So as we have introduced the term time along with the change in the position, so here one concept that we can see, if an object is changing its position equal distance, if it is traveling in equal interval of time, then the phenomenon that we say is it is in uniform motion. That means a particular object is traveling equal distance or equal path in a particular duration of time. Suppose an object travels 1 meter in 1 second. In next second also it travels 1 meter. In the third second also it's traveling another 1 meter. So what we observe, that in each second the object is traveling a distance of 1 meter. As the object is covering a distance of 1 meter in 1 second and it continues to do so in the coming seconds also, we say that the object is traveling equal distance in equal interval of time, and we call such type of motion along a straight line. So here again we need to keep it in mind, the motion we are describing is a straight line, and that will be uniform motion. Now the opposite is when an object will travel unequal distance in a given duration of time. We will call it as non-uniform motion. For example, a car going on a straight road, because of the traffic jam, it travels unequal distance in equal interval of time. For example, it takes 10 minutes to travel a distance of suppose 20 kilometer. In another 10 minutes, it travels only 10 kilometer. So here what we see, the time frame is same, that is your 10 minute, but the distance travelled by that particular car in a straight line is different. In first case different, and the second case it is different. So if an object is covering unequal distances in a given interval of time, we call such type of motion as non-uniform motion. So dear students, at this point let's have a look at a video from which you can clearly understand what is uniform motion and what is non-uniform motion.
Uniform and non-uniform motion. Motion involves the changing of an object's position. Let's consider a rubber ball that's just sitting on a table. If we push the ball, it will move from its original position. The force created by a gentle push has set the ball in motion. Motion can be one of two types, uniform and non-uniform. First, we will look at uniform motion. Imagine someone riding a bicycle down the street. He covers 30 feet in 2 seconds, another 30 feet in 2 more seconds, and another 30 feet in 2 more seconds. In this instance, the cyclist covered equal distances in equal intervals of time. An object moving at a constant speed, covering equal distances in equal time intervals, is in uniform motion. Let's see how the cyclist's uniform motion can be represented on a graph. On the x-axis, we will mark time in 1 second intervals, and on the y-axis, we will mark the distance travelled in 10 feet intervals. For the first 2 seconds, the distance covered is 30 feet. Draw a line from 0 to the point on the graph where 30 feet and 2 seconds intersect. The second point is at 4 seconds, where the total distance covered is 60 feet, 30 plus 30. Mark the place where 60 feet and 4 seconds intersect. The third point is at 6 seconds, which intersects with 90 feet, 60 plus 30. If we connect the 3 points, the graph will be a straight line. Uniform motion will always be shown as a straight line graph. Now let's imagine another cyclist on the road. This one is covering 20 feet in 2 seconds, then slowing down and covering 10 feet in the next 2 seconds. Then he speeds up and once again covers 20 feet in the next 2 seconds, but slows down in the next 2 seconds and covers only 10 feet. An object moving at different speeds, covering different distances in equal time intervals, is a non-uniform motion. Let's plot a graph for non-uniform motion. The first point will be where 2 seconds intersects 20 feet. At the second point will be where 4 seconds intersects 30 feet, 20 plus 10. And the third point will be where 6 seconds intersects 50 feet, 30 plus 20. The final point will be where 8 seconds intersects 60, 50 plus 10 feet. When we join all the points, the graph will be a jagged line instead of a straight line.
So, in the video it was very much clear that if an object covers equal distance in equal interval of time, we call it as uniform motion, And if the object covers unequal distances in equal interval of time, we call it as non-uniform motion. And if we represent those motion in graph, then the uniform motion will have a straight line, whereas in case of non-uniform motion, we will have a zigzag line. So that's how we can represent uniform and non-uniform motion in a graph. Now moving on to the next concept is when we introduce time interval and distance. So that rate at which the distance of that particular object is changing, or if we see how far that object has reached in a given time period, we introduce another concept that is called as the speed. Speed is nothing but the total distance traveled by an object in a given duration of time. So if you start from a position, we reach at another position, we will calculate the distance between it, and the time duration taken by that particular object to cover that particular distance, we will call it as speed. And again, here we will only concentrate on the magnitude. So speed is only related to the magnitude, that is the distance traveled and the time taken, that will give us speed. And as you know, speed is given by the unit meter per second, because the SI unit of distance is meter and the SI unit of time is second. So the SI unit of speed will be meter per second. And as I told, the rate of motion of an object is to find out the distance traveled by the object in a unit time. So at this point, as we have already introduced the time duration or the time interval for the change in the position of an object, let's introduce another term related to the rate of a motion of an object, is that speed. So how do we define speed? Speed is defined as the total distance traveled by the total time taken. Suppose we start from a position and we reach our end position. We calculate the total distance between the initial and the final position and the time taken by us to reach that particular position. So that will give the speed at which we have moved. And the quantity is nothing but your magnitude. So here speed is a quantity that we only specify by its magnitude. There is no direction for it. And the SI unit for your speed is meter per second. As all of us know, the distance is given by meter and the time is given by second. So the SI unit will be meter per second, and this is represented m per s or ms 1 minus, that you can see in the screen also. Now at this point, let's have a look at a video in order to understand what is the rate of motion or how do we calculate speed of an object. So here is the video for you.
Hi, I'm Remo. I work with Speedy Pizza, 100% on-time pizza deliveries. The back office team always helps us keep our reputation. But today, they are busy. Can you help? All you need to do is calculate the speed at which I should travel to make my deliveries on time. Calculating speed is really easy. Just divide the distance by the time taken to cover that distance. Whoa! Our first pizza call for the day. I have to travel a distance of 30 kilometers in 40 minutes. Let's figure out what speed I should travel at. The formula for calculating speed is distance divided by time. 40 minutes is 2/3 of an hour. Divide 30 kilometers by 2 upon 3 hours. And you get a speed of 45 kilometers per hour. So, I must travel at a minimum speed of 45 kilometers per hour to make my delivery on time. Phew. My next delivery is 12 kilometers away and I have to reach there in 20 minutes. At what speed should I drive there? Enter the correct speed in the speedometer and click submit. You got it! I have to travel at a speed of at least 36 kilometers per hour to get there on time. Let's speed away!
So I guess the video was quite clear and you understood how to calculate speed of an object. Now if you talk about the total distance, in that video also you saw in the first case it traveled 30 kilometer and in the second case it traveled 12 kilometer. So now if we want to calculate the average speed of that person or any object, because if you see here we have a non-uniform motion, because the time frame is different, the distance traveled is different. So in those cases, how do we calculate the overall speed of an object? In that case, we go for the total distance and we take upon the total time traveled. Suppose in the first case it travels 5 kilometer in 20 minutes and the second instances it travels 10 kilometer in 15 minutes. So what we need to do in order to calculate that particular speed, that we need to add the total distance and divide it by the total time taken, that will give us the average speed. So dear students, we will conclude today's discussion here only. Let's recall what we have studied so far. We discussed about how to specify the position of an object, that is by indicating the origin. We discussed about distance and displacement and we discussed about speed. So now let's look at some questions and let's evaluate ourselves how far we have understood that concept. So here is a question in front of you. What does the path of an object look like when it is in uniform motion? You have already seen a video, we have already discussed about it. So the answer is quite easy. That is, it's a straight line. If you represent it in a graph, that uniform motion will look as a straight line or a motion of an object in a straight path, and if you represent in a graph, it will be a straight line.